Well, I can't say it's super random. It is random, but it doesn't follow the distribution. So when we do a two-sample t-test and normality is violated, like in our example, we can use a non-parametric test. They are called distribution-free tests because they do not need a normality assumption in most cases. In addition to that, one can use these tests with really small sample sizes. Most parametric tests, such as t-test that we saw, would require a substantial number of observations, at least 30, 40. But here you can make do with 10 observations, 15 observations. So they do not depend on distributions, non-distributions, and in addition, small sample sizes. But, you know, all good things come with problems. There's one big caveat. Can I raise this up? Do we remember Paul? The one. A disadvantage of non-parametric tests? It's minor. If I have to derive a mathematical formula for the null distribution, then it is extremely difficult with non-parametric tests. T-test, t-distribution, normal distribution, easy. We've got formulas for all of it. But here, it's a problem. And two, they require simulation. Because of that, they increase computational complexity. So a t-test, straightforward, but here, if you want an exact value, then we have to simulate, and it is going to take a lot of time. The two cases that we did, erase this slide. We did a t-test, dependent case. We did a t-test, independent sample case. Luckily, both of them have non-parametric equivalence. Do we remember?
No, but that is the one.
Starts with the letter W. Oh, you need to have will. Yeah.
Oh, no.
Oh, will.
Well, no, it was like the Welsh, but
Will.
yeah, it starts with
Wilcox.
W. I have it in my notes.
So we have two non-parametric tests that we can use. Wilcoxon sign rank, Wilcoxon rank sum. Key word here is rank. Non-parametric tests are based on order statistics in the sense you're not going to test for mean, rather it should be median. You have to put the data in order and you have to rank them and then use the ranks to determine if there is a significant effect or not.
So is the Wilcoxon sign rank only exclusive to dependent t-test?
Yes.
And then the other one for only the independent?
Yes.
Okay.
So the equivalent of Wells test, for instance, is rank sum. There is sign rank. One more thought. One may ask, well, if we have this, why bother with that?
It's not that close.
Right? Because, again, those reasons. If you have the small sample size, sure, we can use this. But oftentimes a non-parametric test will give you an approximate p-value. And people will not be happy with an approximate value because maybe you end up with the wrong conclusion. So if those fail, then I can go to these. Reason one. Reason two, these are things statistical nerds like me know well. Not commonplace. People usually go for this easy, straightforward to understand. So, since we did independent samples lately, we will do Wilcoxon rank sum next, and then we'll go back to the paired sample case, and I'll show you how to do Wilcoxon sign rank. Good. I'll only go or do bit of theory, then we're simply going to use
The Wilcoxon rank sum is on page 70 of the textbook.
Oh,